Okay, this lesson is on arithmetic sequences. Now, in the last lesson, we talked about sort of a hodgepodge of things, everything we were going to talk about in this unit, including sequences in series. But today, we're going to talk about specifically arithmetic sequences. So, first thing is, we sort of already defined this, is what is an arithmetic sequence. An arithmetic sequence is a sequence whose terms differ by the same number using addition. Hence the arithmetic sequence. That's addition. Sorry, that's terrible. That is a sequence whose terms differ by the same number using addition. So things are going to be constantly being added or subtracted to form the sequence. The other part that it's going to be important to know is what is the common difference. We sort of introduced this last class, but the common difference is the number added to the previous number previous number, I should say previous term. It's the number added to the previous term to get the next one. And it's referred to as D. D in these arithmetic sequences will refer to that common difference, or what's being added or subtracted to make the next number. So let's look at some of these examples of what these sequences can look like. So in the first one here, it says we're going to decide whether the sequence is arithmetic or not, and then identify the common difference if so. So to figure out whether there's a common difference, you want to see if the same numbers are being added or subtracted every time. So if you can see here, the difference between 1 and 4 is 3. The difference between 4 and 7 is also 3 and 3 and 3. So yes, this would be arithmetic. That's an R, arithmetic. And the common difference, or D, will equal 3. And that's pretty much it. So let's look at the other example. Okay, here. So now this one's actually going down. So it's actually subtracting 2. So in this case, it's still arithmetic, but the D value is going to be negative because it's subtracting 2 each time. So that is just being able to find whether it's arithmetic and then what the common difference is. So the meat of this is going to be actually writing formulas for these specific sequences. So the formulas for arithmetic sequences, fairly straightforward. But then again, there's a lot of formulas in this unit. The formulas you will not have to memorize. You'll just need to know how to use it and what it's used for. So the formula for an arithmetic sequence you will use to find a specific term within the sequence. And so if I asked you for if here's some terms or here's some information, can you find the 50th term or something like that? And this formula will allow us to do that. So what it is it's a of n equals a sub 1 plus n minus 1 times d. Some of these you should be familiar with. We used them in the last lesson. But a sub n is going to be the actual term itself. Whatever the answer is, that's what that is. A sub 1 we should recognize. A sub 1 is the first term. N is the term number. So if it's the fifth term, you would put 5 in there. Sixth term, you would do 6, and so on. And then D, we already described, is that common difference. I'm going to abbreviate it here. Common difference. So how do we use this? So we're going to look at this. So that's the formula. So an example, there's a couple ways that this can be given to us. One, they can give us all or some of the numbers within a sequence, a series. It's actually giving us a sequence of numbers. And this is the easiest method or easiest type of problem to figure out because they actually give us this a portion of the sequence. So all we need to do is just find all the missing pieces. So in order to write the formula for an arithmetic sequence, all you need to write the formula is the first term and the common difference. So the first term's easy. It's right there, okay, negative 12. And then the common difference is found as what's the distance between those, or difference between those. Since it looks like it's going up, negative 12 to negative 9 to negative 6 to negative 3 to 0, it's a positive 3, 3, 3. So my D value is going to be 3. And then all you're going to do is just plug this into the formula. And that's it. So the formula, and I'll choose it, let's use black here. The formula is A sub n, equals A sub 1, or the first term, which we have, is negative 12, plus parenthesis n, we don't know n, because that's what they're going to ask us, is what term we want, minus 1, and then D is 3. And then all you're going to do is just sort of simplify this. I have to distribute the 3 in here, so I get, let me move down a little bit. Okay, I have negative 12. When I distribute that, 3 times n is 3n. 3 times negative 1 is negative 3. Combine like terms, and I get A sub n equals 3n. Negative 12 and negative 3 is negative 15. And that will serve as my formula for this sequence. Okay, this is the formula for this sequence. So now we can use that to find any number within the sequence. So for example, it asks us to find A of 15. So A of 15 is asking us to find what is the value of the 15th term. So we can figure that out by doing A of 15 equals, and just plugging in 15 in for n. So 3 times 15 minus 15, A 15, or the value of the 15th term, 3 times 15 is 45, minus 15 is 30. So the value of the 15th term would be 30. And so that's how we use arithmetic sequences. They're pretty basic. And again, this is the easiest type when they actually give you the sequence. But, I mean, that's essentially what you do. And that's what we're going to be doing each time. So, let's try another one. I kind of leaked over into this space here. But we're going to do this anyways. Let's change colors here. So, again, to write the formula for a sequence, you need the first number and the common difference. So the first number, it's easy, it's 55. Okay, it's right there. And then the common difference looks like it is going down by 8. So it looks like our D value is -8. So now when we go to plug this in the formula, so the formula again is A sub n equals A sub 1 plus n minus, I just did that, n minus 1, messed that up. Let's go backwards. Minus 1 times D. So I'm just going to plug everything in. So A sub n equals A sub 1, which is the first term, plus n minus 1 times D, which is -8. Again, this needs to be distributed. So I have 55. -8 times n is -8n. -8 times -1 is +8. And so A sub n is, combine like terms, -8n plus 63. Okay. Now again, it says it wants me to find A sub 15, so I'm going to find the 15th term by plugging that in. A sub 15 will be -8 times 15 plus 63. And when you do that, -8 times 15, I think is -120, and then plus 63 is -57. And so that will be the value of the 15th term. Well now, so let's look at now, so that is if they give you the sequence. If they give you the sequence, makes it real easy, take the first term, find the common difference, and then just plug it in to your formula up here. But, and there's always a but, right? When you flip the paper over, what happens? And things start to get harder. So what happens if they don't give you the sequence, and maybe they don't give you the first number or the common difference? So those are the type of problems we're going to do next. Okay, so in this problem here, and let me zoom in. Okay, in this first example here on this page, it says to write a rule for the nth term of a sequence where a of 19 is -45, and the common difference is -3. So here's a type of problem where, remember, to write the formula for an arithmetic sequence, you need the first term and the common difference. And here's an example where they don't give you the first term. Now, since you know that the terms are subtracting by 3 every time, you could sit there and go and figure out the 18th term, then the 17th term, then the 16th term, then the 15th term, then the 14th term, then the 13th, and all the way down to you got a sub 1 and figure it out. But that is often too tedious, and there's so much room for mistakes. So there is another way to do this, to figure out the first term algebraically. Now let's write the formula up here at the top so we don't have to keep flipping back and forth. So the formula is a sub n equals a sub 1 plus n minus d. That's a minus, not n minus d. What am I doing? N minus 1 times d. So there's our formula that we're going to be using. So in order to do this, we have to find a sub 1. We need the first term to write the formula. We have d, but we need the first term. So step 1 is going to be, if I can zoom in here, is going to be find a sub 1. Now how we do that, so if we write the formula here, and maybe I'll do this in different colors so we don't get confused here. If I write the formula a sub n equals a sub 1 plus n minus 1 times d, you're essentially looking for a sub 1. Now, the good news is it did give us one of the terms. It said that, hey, the 19th term is -45. Let me see if it's saying, hey, the 19th term, or n, is 45, or -45, which is a of n. So we can plug that information into our formula, including the value of d, and figure out what a sub 1 is. So I'm just going to plug everything in. So a sub n for their given information was negative 45. We don't know a sub 1 plus. We knew that negative 45 was the 19th term. And then our d value is negative 3. And so we just solve for a sub 1. Well, 19 minus 1 is 18. 18 times negative 3 is negative 54, so I have negative 45 equals a sub 1, and it's negative 54 over here when you do that. So I'm just going to add 54 to this side, and I get a sub 1 equals 9. So now I have the first term and I have the common difference, so now I can write the formula. And that's what we do next. So step 2 is write the formula. Okay. So now I'm going to use what we have here, and I'm going to take this and we're going to go over here to write the formula. So here's d up here, and I have a sub 1, so now I'm going to write the formula. So the formula is a sub n equals a sub 1, which I now know is 9, plus n minus 1 times d, which we established is negative 3. So, as we're just doing essentially what we just did on the previous page. Now, given the a sub 1 and the d, just plugging everything in, distribute. So I have 9, negative 3 times n is negative 3n. Negative 3 times negative 1 is positive 3. Combine like terms, and I get a sub n equals negative 3n plus 12. And so now I have my formula. And lastly is to answer the final part of this question, and that is find the first 5 terms of the sequence. Well, all we do is just plug this in. This is sort of what we did last class now. So let me change colors here. The 5 terms of the sequence, I'm going to create a little table here, and then n, and then a sub n. So 1, 2, 3, 4, 5. Now I already know the first term, because that's what we found. The first term was 9. The second term, we're going to plug in 2 into our formula over here. So we're going to plug in 2 here. So negative 3 times 2 is negative 6, plus 12 is 6. Then you'll plug in 3 in here. Negative 3 times 3 is negative 9, plus 12 is 3, and you can sort of get the pattern here. 9, 6, 3, that's going to be 0, and this is going to be negative 3. So our sequence for the first 5 terms is 9, 6, 3, 0, negative 3. Okay. And so that's the way to get around it. So that's an example where we don't have the original amount. We don't have the first term, but we have d, and we have a given term that a of 19 was negative 45. So we use the given term in our formula and the value of d to solve for a sub 1, and then be able to write our formula. So the last example, or last type here is, what if we're not given either? What if we're not given the first term or the common difference? So this poses a problem because we don't have any of the information that we need to write the formula. But we are given that t of 3 is negative 5 and t of 6, or term 3 is negative 5 and term 6 is 16. We can use that to find the common difference. Because we know that the third term is negative 5 and the sixth term is 16, we can actually use that information to find the common difference. So the first step is going to, we need to find that common difference. So find d. Okay, so finding d. So what we do to find the common difference, given 2 different terms here, is we're going to take the difference in the terms, Okay, so these are the terms. Oops. These are the terms, and then the 3 and the 6 are the term numbers. So we're going to find the difference, negative 5 minus 16. We're finding the difference in the terms over the difference in the term numbers. Sort of, you know how you find like slope, difference in the y's over the differences in the x's. You're finding the difference in the term numbers over the difference of the terms over the difference of the term numbers. So what we end up getting is negative 5 minus 16 is negative 21. 3 minus 6 is negative 3, and so we get that D is 7. Okay, subtract the term numbers over the term, I keep saying that wrong. Subtract the terms and divide them by the term numbers, and that is how you find D. It's going to take a little bit of practice to remember that. Which ones go on top and which ones go on the bottom. The terms go on top, the term numbers go on the bottom. So now that we have D, we are essentially going to do what we just did in the previous problem and use D in one of my terms to find A sub 1. So the next step is going to be to find A sub 1. And to do that, we're going to do exactly what we just did in the previous problem. Remember, A sub n equals A sub 1 plus n minus 1 times D. And so we know D. Let me sort of highlight this. We know D now, and we can use one of our given information. Personally, I don't like to work with negatives, so you can use either one of these terms in here, but we can put them in for the terms and then the term numbers to solve for A sub 1. You can use either one, it doesn't matter. Again, I don't like dealing with negatives. So the term is 16 A sub 1 plus, and the term number was the 6th term, and D is 7. So what I get is 16 equals A sub 1. 6 minus 1 is 5. 5 times 7 is 35. I subtract it over. So I get that A sub 1 equals negative 19. Okay, and so now I have everything I need. I have my A sub 1. I have my value of D. So the last step is going to be now to write the formula. Oops. Select the pen. Write formula. Scoot this down a little bit. Now, since I've sort of run out of room here, I'm going to take this around over here. Oh my gosh, there you go. So again, the formula I'm going to use this formula right here. So when I write this, A sub n equals A sub 1, which we now know is negative 19, plus n minus 1 times D, which is 7. We distribute, so I get negative 19. 7 times n is 7n. 7 times negative 1 is negative 7. Combine like terms, and I get A sub n equals 7n. Negative 19, negative 7 is negative 26. And then the last part here, they do ask us to find the 10th term, to sort of compromise space, but you can see here they want us to find the 10th term, so all I simply do is just plug in 10. So A of 10, meaning the 10th term, is 7 times 10 minus 26, which 7 times 10 is 70, minus 26 means that the 10th term will be 44. That is all the different examples. So you have If you're given the sequence, it's easy because you can use the first number and the common difference. But sometimes you're missing those. In this top example here, we were missing the first term, but we had the common difference, so we could figure it out. Here we're missing both, so we had to find the common difference, then use that to find the first term to end up writing the formula. The last questions here are word problems, but it's exactly the same thing. So basically, they're giving you a sequence. So Rebecca makes $12 in her first hour, $17 in her second hour, and $22 in her third hour, and so on. So how much is she going to earn for a 50th hour of work? Well, they're giving us a sequence. They're essentially telling us that the sequence is 12, 17, and 22. So we can use the sequence. Here's our first number, our first term, second term, third term, and we can use that to find the common difference. Well, it looks like it's going up. Let me get rid of all those. It's going up 5 every time, so now we have the common difference. So we have that a sub 1 equals 12, and we have d equals 5. We have everything we need to write the formula. So when I go to write the formula, a sub n equals the first term plus n minus 1 times the common difference. Plug that in. I get 12 plus 5n minus 5. Combined like terms, I get a sub n equals 5n plus 7. And that would be your first, or your equation for that formula. And then it asks for what would she earn her 50th hour of work. So basically the 50th term. So if I substitute that in, a of 50 would just be 5 times 50 plus 7, which would be $257. It's a terrible circle. There you go. All right. And this last one I sort of doesn't really fit in here, but it is something that you do need to know. So this is an example. So it says find the 4 arithmetic means between 10 and 30. So basically, it's wanting the terms that are in between 10 and 30. So it knows one end is 10 and the other end is 30, but it wants the middle terms. So how you can write this out is to write 10 on one end and 30 on the other, and just put 1, 2, 3, 4 blanks. You're trying to find the 4 terms that are in between. That's what it means by arithmetic means, the 4 terms that are in between 10 and 30. Since you know they're arithmetic, you know that they increase by the same amount every time. So remember how we did how we did the example above when we were given one end and the other. How did we find the common difference? Well, remember, you subtract. So you subtract, this would act as your first term, second term, third term, fourth term, fifth term, and sixth term. You would subtract the terms, 10 minus 30, over the term numbers, 1 minus 6, and this will get you the common difference. D equals the terms, some difference in terms over the difference in the term numbers. You end up getting negative 20 over negative 5, which is 4. So our D value is 4, so simply I just add 4 every time. 14, 18, 22, 26, and that would be the last term would make that 30. So there's our 4 arithmetic means. And that's it. Let me know if you have any questions. Thanks.